You've learned how to estimate linear measurements with reference, and in this lesson we'll look at how we can estimate areas using a similar sort of technique, only this time our reference is going to be a square of a known size. So let's try to use a grid to estimate the area of a shape. So we have to be given a referent. In this case, we're given a little referent that's 1 meter by 1 meter. That means that the square is 1 square meter. 1 square meter. So now what we can do for our larger shape is count up the number of those square meters inside of it. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and you go through like that, and you count up each box, and in the end, I count an area of 24 boxes. Now, if each box is a square meter, this must be 24 square meters, or 24 meters squared. In this case, it was very easy to get an estimate because it was rectangular. I want to show you one more example where the shape's a little more complex. So let's try to estimate the area of this lake with 1 square kilometer referent. We need a grid, so let's put that 1 square kilometer grid over the lake, and now we have to get to counting. So I'm not going to go through all the details of this for you. I'll show you my initial round of counting. So here's my first attempt at counting all the full or mostly full square kilometer boxes. And you can see I counted 47 to start with. You don't have to put numbers on every single one. Sometimes you just use little dots to keep track. And now the next part is that we have to round up the rest that haven't, counted as full square kilometers. So you might do something like grouping these 3 boxes at the top together and saying, well, those 3 together would create pretty close to a full square kilometer. Maybe these 2 along the side as well, and these 2 here. And you sort of run through like that, grouping together the leftovers. And I'll show you what happens when I finish that. So here we are. I grouped together boxes that were nearby each other and said, okay, well, these together would create a full square kilometer. And if I count up these groups that I've made, 1, 2, 3, I count a total of 13 square kilometers that I've grouped together. And then there's these leftovers that I've put dots on that I didn't really get to. And here's just a time to estimate and say, all the stuff I missed, maybe there's 5 or 6 square kilometers left over. So I'm just going to add 5 square kilometers to that for our leftovers. So now we can just do a total count, for our area estimation. So we had 47 square kilometers from our initial round. And then from our 2 combined sort of trying to get the leftovers strategy, this would be 13 plus 5 is 18 square kilometers. So to our 47 square kilometers, we'll add 18 square kilometers. And this gets us 65 square kilometers. So this would be a pretty reasonable estimation for the area of the lake. If you said 60 square kilometers, that would be fine. If you said 70 square kilometers, that would be fine, as long as you showed some work to justify how you got to that number. It's not a totally precise method, but as long as you can get reasonably close and show how you got there.